In this video, I'm going to talk about Python lists. I'm going to go over the basics and show you some fun and interesting and useful things to do with them. So let's start with what a list is. So a list is a sequence of items that are enclosed in brackets and they're separated by commas. That's basically it. You can put a list of, you can have a list of numbers. You can have a list of strings, of booleans, of objects. You can have a list that mixes all of those things up. So simplest case I usually find is to use a list of numbers. So here we have nums and we got how many items? 2, 4, 6 items in here. So I'm going to go ahead and print that to demonstrate. It's exactly what we'd think. Looks exactly like what is typed here. All right, that's like a sort of how we construct a list. If we want to do something interesting to this, such as get the first item, we can use this bracket syntax, which says to go from nums, we're going to go some number of offsets from the beginning of nums. The syntax is sort of a holdover from older languages, but let's just think about it in terms of the number we put inside these brackets is the number of offsets from the beginning of nums. So let's try with 0, right? How many offsets do we want to go before we get to 3? No offsets at all. So that'll give us 3. If we wanted to get 9, how many offsets would we need? Well, we'd have to go 1. So I'm going to put 1 in there. And that'll give us 9. And if we wanted to try to get the value -1 out, we need to go 0, 1, 2, 3, 4, 5 offsets. And then we get -1. It's a bit tedious to put these numbers in manually, like in the example of where we're getting the last item in nums. So we can do that in a different way. But before I do that, actually, I want to show you the way I think about this. So if you want to get the first item, it's the index 0. The second item, it's index 1. Third item, it's index 2. So the equation that you might want to have in your head for that is simply like the sort of, I don't know if it's called the ordinal number, but like when you do the nth item, the index of the nth item is n-1. So the fifth item, the index is 5 minus 1, so 4. Okay, so we have a way to get at the values in the list. And if we want to get the last item, we can always use this length function on nums. So if we just use length, it'll give us an error because we're going to go beyond the end of the list. So I'll demonstrate that now. Right? List index out of range. And that's because, let's see, 2, 4, 6 items. We actually don't have an index 6. Right? We have an index 5, which corresponds to -1. So we want to use this equation I just mentioned. If we want the 6th item, then we want to take 6 minus 1 and put in 5 to get the index 5. That should always give us the last item, -1. Right? So if we add things to this list, add 2 more items, we should always get the last item because we're calculating this this value, this length of nums dynamically every time we run it. So get 10. Cool. So we learned how to index. We learned how to get the last item using the length function. What else would we need to do with lists? Well, we can actually do something pretty cool with lists. We can use the Python slice notation, which involves using 1 or 2 colons. I'm going to start with 1. So if we wanted to print out the exact same thing we have already on line 3 with the slice notation, we would start with 0, which is the start index, and then the index we want to stop at, meaning we go up to but we don't include. Basically, we want to put an 8 there because we want, let's just verify. And that's because the final index, 0, 1, 2, 3, 4, 5, 6, 7, is 10 is at index 7. So what we've said is to go from 0 all the way up to index 8, but don't include index 8, right? So we could, I guess, also do len of nums. That way, if we add more values, it'll always give us all of the values. Okay, so the shorthand for that is actually just a single colon. So you don't even need to go and worry about the length. If you want the first all the way through the end, you can do that. You can also put another colon here because there's actually a third value. There's this whole start, stop, and then step index. It's not an index, it's a step value. So you can leave all of those out. They all have defaults. And this means like basically 0 through the len of nums, right, with a step of 1. So if we so we can take nums and we can start at the first item and then go to the end, which is the default, and then we can do every other step. The step is 2, so we pick every other item. So I think we'd get 3, 6, 12, 4, 12, 100. 3, 6, 12, 4, 12, 100. Let's see if we get that. That gives us every other, starting with the first index we've specified. If we wanted the same sort of step but offset, where we'd get 9, 0, -1, 10, 0, we could just put the number 1 in there. 9, 0, -1, 10, 0, yeah. Slices are useful if you want to succinctly express that you want every other, every third. Let's see if we can do every third but in reverse. Cool. So this way, if we don't put any starter or stop and then use the reverse, we can start at the end and then go every third. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah. So that's why it gives you 100, 10, 12, and then 9. Slices are useful. They can get a little confusing sometimes if you're trying to go in reverse. Next, I'd like to talk about other aspects of lists, like you can add them. They have addition and multiplication defined for them. So if I did nums plus nums, and then printed that, you get basically the list doubled. So there's just like one added on to the other one. So it's kind of like an append, except it's here we're creating a copy. So it's sort of merging the two lists into a copied version of nums, but double the size. So if we wanted to do list, what if we want to multiply nums by 2? What do we get when we do that? Okay, this is actually the same thing. So it's like adding nums to itself, but if we wanted to multiply it times 4, probably be like adding nums to itself a bunch of times. Yep, so it's just a repetition of this. So it's interesting, you can create repetitive sequences if you wanted. Imagine, I don't know, these are amplitudes or something of a wave, you know, and if you wanted to make the wave repeat 4 times, you could just multiply it by 4. This does not work for division, and it doesn't work for subtraction, just to note there. You could create your own class and define those operations using the under methods. But just out of the box lists, you can add and multiply them. I don't think you can multiply a list times a list, but let's just see. Yeah, you can't do that. And you can't do like nums plus 4, I don't think, because that also isn't defined. If you want to add an element to a list, you can do it in this way. Let's take a look. So say we have this list of nums and we want to add 1,000,000 to, or let's just say like 1,000 to it. Nums append 1,000. All right, so the value here, you can see at the end, we called append 1,000 on nums, and then we printed. So in this case, it's actually modifying nums itself, and then later we're printing that value. Trying to think of, we could use extend, I believe, as well. So I think extend takes it takes itself a list argument. So the cool thing about that is extend takes a list. So basically it concatenates, or it appends a list onto the end of an existing list. Whereas that wouldn't really work. If we can't really call append with multiple values, I don't think. So let's try that. Yeah, it takes only one argument. So just to recap there, if you want to append to a list, you can only do one item, and that's going to put that item at the end of the list. And if you want to extend a list with multiple items, you'd use the extend method and pass it an array, and it would take each item and add it to the end of nums. So I have another video on list comprehensions, which I'll link to at the end of this video. So that's more of like an advanced use case for lists, but I'm trying to think of anything else that we would want to cover to use lists. Another cool thing we could do with lists, we can take a look at some of the methods that are on the list object itself. So we talked about append, we talked about extend. We can also do, we can sort it, right? So that's cool. That means we're going to get these numbers in ascending order. Let's print out nums. All right, so yep, -1, 0, 0, 3, 4, 6. It's ascending all the way up from -1 to 100. That's cool. Another thing we might want to do is count. Count's a nice one. So we're gonna, let's say we have some items here. Do we have doubles of anything? Yeah, we have double of 0. So if we count 0, basically it's giving us 2 back, which means there are 2 instances of the value 0 in the list nums. So that's one way to get like a count of a specific value there. We should talk about push and pop. So let's print nums. So I'm printing out nums, and then I'm popping nums, and then I'm printing out nums again. So what we have here is we had 100 at the end, but when we call pop, it just takes off the last element. We can do it. We can keep doing that. And if we print, we popped a bunch of values. Say I call it 6 more times. Gonna have an empty list. No values left. If I do it one more time, you're gonna get probably an error, right? Pop from empty list. So you can't call pop forever and it won't pop from an empty list. It'll give you an error. What we could do is push. So nums, and we already know push. We can do append, right? So we popped everything off, we appended something. Pop and append are sort of inverses of each other. Okay, that's enough, I think, for list basics. So thanks for watching, and I'll see you in the next video.